I really enjoyed making this project, the video not so much. I just hated it, to be honest. But in all seriousness though, I like this project because it lets you see things from both the attackers and the defender's perspective, because we would be using a honeypot, and it's a security tool that acts like a decoy, and it is designed to attract attackers, tricking them into interacting with the honeypot. This lets the defenders to study the hacker's methods. Like in some cases, extremely rare cases to be honest, the attacker would use a zero-day exploit, so that is some valuable information that we can utilize to improve our real system defenses. And even if the attacker didn't use any zero-day exploits, the honeypot would still distract them from the real target and waste their time. And the honeypot we would be using is Cowrie, and this would run a fake secure shell server on port 2222. And the next definition we need to cover is brute forcing, and it's a hacking technique where an attacker tries every possible combination of username and passwords until they find the correct one. It's basically a trial and error method to break into a system, and the tool we're gonna be using for brute forcing is Hydra. And the next thing you need to do for the project to work is changing network address translation or NAT to bridged adapter on both of the machines, so that the attacker's machine, the Kali Linux one, would be able to detect and attack through brute forcing the defender's machine, the Ubuntu one that would be hosting the honeypot with a fake secure shell server. After activating your Ubuntu machine and creating a user, you should run this command just to upgrade and update the system. And we would also need some tools to make a Python virtual environment so that some Python libraries for the Cowrie program wouldn't intervene with other programs. You don't actually need to set a virtual environment, but that's just a good practice, not a requirement or a necessity. Then we would download the Cowrie repository through the clone command, and then we navigated to the Cowrie directory, and with this command we created the virtual Python environment. After that, with this command we actually activated the Python virtual environment so we can install some Python upgrades and download all of the requirements inside of the requirements file. And then we run the IP command just so we can know what is our IP address, because we would need it in some commands later. And then we should navigate to the etc directory so we can copy the contents of the userdb.example file to a new userdb.txt file, and you can modify the new file if you want, but I would choose not to. And basically the contents of the file say that every login credential an attacker would use, it would work, and the attacker would be able to access the fake secure shell server unless he used 126 or root as a password. So if you want to exclude a password or a username, just put an exclamation point and type the username or password you want to exclude. And the next thing you would be doing is executing a command that redirects all of the traffic going to the 22 port of the actual legit secure shell server to the 2222 port, the one that has the honeypot or the fake shell in it. And now you should turn on your Kali Linux machine and enter the terminal so we can use the Hydra tool for brute forcing. The first thing you should do is type Hydra in the terminal. Then if you want to test the username of a secure shell server, you should type dash lowercase l, and if you want to use a username list, you should type dash uppercase l, and if you want to test one single password, you should type dash lowercase p and type dash uppercase p if you want to test a list of passwords. So let's actually try brute forcing with Hydra. As you can see, we used admin as the username we want to test, and we used a short passwords list. In actual attacking cases, the brute forcing would take more time and would use bigger lists, but in our case we just want to demonstrate how this works. And then you should type secure shell : / and then your IP address. After the dash s, you can put the number of the port you want to connect to. Because we already set that file rule, we can put 22 because we would be directed to the port 2222. As you can see, basically each brute force attempt was successful because we want to trap the most amount of attack as possible. But if it was a real secure shell server, it would only accept one user with one password. So I guess there are ways for hackers to say, oh, maybe this is a honeypot and I'm just wasting my time. But that's fine. And then if you want to see the logs of the honeypot, you should navigate to the log directory, then enter the Cowrie directory, and you would find the logs in a JSON format. And when we look inside the file, you would notice that the same credentials that were used in the brute force attack are shown on the honeypot logs. And after getting the right login credentials, the hacker would probably try to log into the quote-unquote secure shell server. So let's say the hacker quote-unquote infiltrated the system successfully and then wanted to execute some commands. As you can see, the shutdown command doesn't work. Only the basic commands are working, like ls, whoami, and cd. And you can create a file, but you can't modify it with the nano command. It also doesn't work when you try to create a username. You would think that everything is normal when you are putting your username, full name, and room number. And then it just gets really funny, because it demands some actual dumb information like what's your favorite movie, and then it asks you if the information is correct, and even if you say yes, just does the whole process all over again, just to waste the attacker's time. So I think this honeypot works best if the threat was a bot. Like there's no way that a hacker wouldn't know that this is a honeypot. But here's the thing, the honeypot did its job already. Let's say someone tried brute forcing with Hydra, and he realized that this is a honeypot because he notices that there are multiple correct passwords to the same user. That would still be useful to us because we can study the attempted passwords and use that information to improve our password security and strengthen authentication on our real systems. So that was it, guys. Maybe in a future video I'ma make the honeypot public and analyze real attacks.